So hello, everybody. I'm very excited to kick off this panel at the ACM Collective Intelligence Conference 2021. As you see, we have a very esteemed set of panelists here, integrating different perspectives on the topic of collective intelligence. It's integrating perspectives from information systems, from psychology, and from behavior. And we look specifically also into aspects of putting collective intelligence into action, right? So that is probably the focus of what we are trying to do here today. Maybe a few words on this fascination on collective intelligence. I think that, of course, it is very fascinating to see collective intelligence, which around the world now, which takes so many different forms, right? So we've seen crowdsourced software development, for instance. We've seen crowdsourced innovation. We see crowdfunding. We also see companies leveraging these mechanisms for crowdsourced innovation processes inside the organization. And it's interesting to see that probably there might be at least two mega trends these days. On the one hand, it is kind of to automate things, and on the other hand, it's probably to crowdify things, right? And so there's a lot of talk about artificial intelligence, and that's probably going very much down this route of automation. But then there's, I think, this extremely fascinating element of collective intelligence, also bringing in kind of people more into the loop and leveraging kind of crowds of people and what we can all accomplish together as a crowd. Of course, and probably our discussion will reveal this also, it's interesting then if we would combine both of those mega trends, right? So on the one hand, kind of we have artificial intelligence, but also we have collective intelligence. And so maybe we have crowds of actors, both man and machine, and they again form sort of a form of collective intelligence, right? So I think there's a lot of super interesting aspects around these topics. However, I see that also when discussing and listening and tending to the presentations we had today already, we see it actually is quite a challenge to put this into action. So there are a few obstacles, a few challenges, and of course, an ocean of research opportunities which come up when you really would like to put collective intelligence into action. And that's exactly what I'm really very grateful to be able to discuss today with this esteemed group of panelists here, which I would only very briefly try to introduce, so we have enough time for their presentations and also a discussion. So let me probably start with Al Hevner, who is a professor and eminent scholar in information systems and management, and he holds a Citigroup Hidden River Chair of Distributed Technology. I think he's most well known for his work on design science, right? So all of us working on, those of us working in design science and working on information systems would be very well familiar with the seminal work Al has done here, and he's really a thought leader on design. So I'm very glad also that he will share his view on design on our topic here today. Al has published in all most prestigious journals of our field, and he has consulted a number of Fortune 500 companies also. He's a fellow of the American Association for Advancement of Science, and he's also a fellow of the Association for Information Systems. And additional honors would include the Schoeller Senior Fellow at Friedrich Alexander University in Germany, and the Parnas Fellow at LERO, the Irish Software Research Center, which is an honor which connects him to the second panelist here, which I'm very happy to introduce also. So the second panelist would be Brian Fitzgerald. I'd say most of us would know Brian. He's director of LERO, the Irish Software Research Center, and he also holds an endowed professorship in innovation and business and technology at the University of Limerick in Ireland, where he also served as vice president research. Brian is currently president of the Association for Information Systems, which is the global body for information systems worldwide. Brian and I once went on a bike tour in the Burren, and I remember remembering this. And specifically for this moment, Brian, you remember when there was this bull just in front of our pathway where we wanted to go, and I understand it was probably only through the quite collective intelligence we were able to bring up together with Brian Donnellan also that we were able to get the bull out of our way. But that was something I like to remember also a lot, Brian. So Brian also PhD from the University of London. And his research interest, most of you would know, is on software development and open source and inner source, crowdsourcing. So crowdsourcing software development, agile and lean software development, global software development. So Brian, in his presentation and discussion, he will take a really kind of a software engineering, a software development perspective here. Also, Brian has published over 17 books and over almost 200 peer-reviewed articles in all the leading journals, not only in information systems, but also software engineering. And interestingly, before Brian became an academic, actually, he also had industry experience, 12 years, including with Citibank in Frankfurt, as well as in Brussels. So moving onwards, Peter Mohr is a junior professor and head of Dahlem International Junior Research Group, Neuroeconomics at Freie Universität Berlin, Free University Berlin. And this is also probably also very much summing up his very unique perspective on our topic here today. Peter and I, we got to know each other at the Neuroinformation Systems retreat, where also Al is a regular participant and contributor to the community. And Peter has an impressive background on understanding kind of behavior and also researching behavior and attitude from a neuroscience perspective. He has a background in business administration, in finance and marketing, but then did a PhD in psychology at Max Planck Research School. Today also his research interest lies very much in neuroeconomics and aging and behavioral economics, decision science in general. And it was very enjoyable. We had the opportunity to publish a paper together on digital nudging. And I can really say I learned loads from your impressive background and theoretical underpinnings and also methodological considerations. So without any further ado, I'd probably like to hand over to Al first, who will give us an insight into challenges of collective design, and then we move onwards to Brian talking on about crowdsourcing software development, and then over to Peter, collective intelligence and attention. We then will open up the floor for discussion. So please, if you have any questions or comments you'd like to raise, take notes, and there will be ample opportunity after the input statements of the esteemed panelists to go into also an open round of discussions. Good. With that said, I stop sharing my screen and hand over to Al to please start sharing your screen, and the floor is yours.
Okay. Well, you still have the screen, Jan. So let me.
Sorry, I don't think so.
Okay, can you see my screen?
We see the graphic recorder screen.
Yes. You see a CBS screen.
Okay, I have shared my screen, so.
Yes. Rob, can you fix that, or shall I share?
Yes.
I think it's possible. So we will need to switch screen. So we have a graphic illustrator who's going to draw the things that you're talking about and try and capture some sort of visual that will bring together the different ideas that you've been describing. So okay. the way to get the proper screen is at the top of your screen. If you click View Options, and then there's a drop down and you'll see shared screen Alan Hevner.
Mm-hmm.
And if you click on that one, we will see yours now.
Yeah, all
Sorry,
right.
that one was running in the background.
I do see it now. Yeah, very good.
So if anyone's interested, instead of following that drawing as well while you're talking, Al, you can flip backwards and forwards and view that drawing.
Well, that's very good. This is collective intelligence, I think, that is happening here. We wanted to demonstrate that to all participants, how useful it can be to apply collective intelligence on problem solving.
Okay, well, if everybody can see my screen, I'll go ahead and get started. So I'm very pleased to be able to, share a design perspective on collective intelligence here. And let me just quickly jump to a figure that sort of demonstrates my perspective on how design does have some really important research questions and issues of collective intelligence. By the way, this diagram that I'm showing you was originally discussed at a NeuroIS conference, as Jan discussed, and it appeared first, a preliminary version in the first paper you're seeing, and then we've expanded on these ideas in a more recent paper that you can see the collaborative nature of that discussion that appeared in EJIS. So. What I've identified in this is a simple 2x2 diagram that shows as you perform design research, how you distinguish the problem space from your solution space, and then the external environment, the real world, from the internal cognitive environment of a design team that is collaborating and sort of building a collective intelligence. And in doing that, there are really four key challenges that we've identified, and I think has a tremendous opportunity for new research ideas in this field. And as you can see, first, understanding the problem space, dealing with the complexity of the real world, and then generating novelty, engaging creativity of the design team in a way that produces novel solution space, parts of the solution space. Then the control needed to refine, to use human judgment to come up with the most appropriate design candidate to bring into the solution space. And then finally, the whole field of collaboration. So let me expand on each of those four just very quickly. The challenge of structuring the problem, I think, is very key and really does require a clear understanding of how we collectively build this type of intelligence to understand the problem space. As we deal with complex systems, they're diverse, interdependent, connected, adaptive, and an important issue is they're socio-technical in that we've got to integrate the human and the technical elements of the design space. It's a wicked problem, and we have a lot of things to consider here. The context, what is our goodness criteria, and the actual dancing landscape we deal with in the problem space of emergent behavior, self-organization, and change. So the research challenge here is, how do we manage this complexity to communicate sort of the mind maps of these complex problem spaces, and how do we support these activities? A lot of the work in this space has dealt with creativity. How do we support creativity in a collaborative design team? So there's been some significant research here. How do we define and support more creative design processes? How do we build a support environment, an infrastructure space? When I was a program manager at NSF for a couple of years, one of the programs I was a manager of was the idea of creative IT. How do we build creative socio-technical systems to support more creative environments here. So again, given the makeup of the design team, how do we deal with issues like trust, diversity, and personality traits that create or impact creative performance? But creativity is not the sole issue in a good design, because we can create many reasonable, satisfactory solutions. How do we use intellectual control and human judgment, or convergent reasoning, to come up with the best solution, or at least a satisfactory, good solution? And how do the issues of bias and noise play in this human judgment as we do this ranking and rating of different designs? So there are a number of key control questions that we address in the Aegis paper, but I think really lead to a lot of interesting research opportunities. And again, how do we define and support processes and tools to enable better human judgment in the face of bias and noise in the team environment? And finally, just the issue of building a design team with good collaborative support structures. We want to build a team of diverse skills, talent, energy, skills come together. But at the same time, part of this collaboration challenge is communicating what we're doing to the stakeholders that are important audiences of the design solutions that we're developing. So again, this whole idea of collaborative emergence and communicating to a collaborative team of stakeholders, sort of the researcher practitioner world that we live in as we build information systems, is important here. Let me end with just a quick example of a recent research project that I was involved in with my doctoral student, now colleague, Ankar Malgande, where we looked at software development teams, and this is a nice segue to Brian's presentation, but we did a preliminary analysis of the tension between control and creativity. So we looked at the idea of how do we develop novel features on platforms, and we did two case studies of real-world industry projects, and we made these following conjectures: that the portfolio of controls in the software development team, there were informal controls that allowed more, if you will, divergent thinking, creative behaviors. But we also saw the importance of formal controls, which again supported the ideas of convergent thinking and reasoning and ranking candidates, so that the teams were implementing the most feasible, effective product features. So we made these conjectures. We found some initial evidence that our conjectures could be correct, and so we're now working on formalizing that in different ways of coming up with better hypothesis and evidence for these types of theories. So let me stop there, and I'll unshare and turn it over to Brian.
Wonderful. Thank you very much, Alan. I love the collaborative emerging
Thank you, Alan.
elements. Brian, the floor is yours.
Sorry.
Great drawing, by the way.
Sorry, I'm trying to share my screen there with a new version of Zoom. So,
yes.
Hello. Right. See, it might be. Oh.
No worries.
So I got to share screen. I'm sure my desktop maybe I might have to do it. not allowing me to share my PowerPoint file. One option might be to hand over to Peter and I get it sorted out. But,
Okay.
okay, yeah, if you hand over to Peter, I need to open
very
system
good.
preferences
Right.
to, so apologies for this. Peter goes ahead out of this sorted out, sorry. There's a new.
Okay, should I go on?
Yes,
Yeah,
you
please,
go.
that's good.
Okay, then I try to share my screen, so perhaps that works. Let's see.
Yes. Yes, it works.
Does it work?
It does. It does. It does.
Okay, so I start. First of all, yeah, thanks to Jan for the kind introduction. Yeah, as Jan said, I'm not at all an expert in collective intelligence, but more so in psychology of decision making and judgments and so on, and its neural underpinnings. But today I won't talk about the brain, so lower your expectations. There won't be any brain pictures. Yeah, but about some structural influences on individual decision making that might be interesting for you experts in collective behavior and collective intelligence. Maybe not, but I thought that at least in my perspective, collective behavior might be driven by these structural influences on individual behavior. So, well, the topic of the whole session is translating collective intelligence into action. What did I make out of this from my point of view? Well, yeah, how does collective behavior emerge and how can we perhaps reinforce collective behavior? And as I said, from my background as a judgment and decision-making psychologist or behavioral economist, I usually take an individual perspective, so perspective on the individual, and then think what might drive collective behavior and look at structural influences. Yeah. So, but before I come to this, the core of my presentation will be about information processing, because information processing usually comes before behavior, and if you want to understand collective behavior, maybe it might be worthwhile to try to understand individual information processing. And yeah, typically there are two kinds of inputs. External information can go into information processing, and internal information. And the external information is typically comes from sensory input. So you look at some things, you hear things, and so on, right? This is the information that comes in, all right? And internal information usually comes from memory. Yeah, something pops up in your brain, and you think about these, and it enters your information processing. And in my short presentation, I will talk about two kinds of structural influences on these two things. First is about sensory input, and it's about visual attention. So how the things you look at influence your information processing and behavior. And the second part will be what drives the input from memory. So what pops up in your mind when you think about different problems and so on, right? And both of these might drive collective behavior and also collective intelligence. And if you want to reinforce collective behavior and collective intelligence, well, you might think of playing around with these things also in terms of digital nudging, right? Okay, then first of all, I'd like to start with a very, very basic problem. So as I said, I'm a decision scientist. If you think of eating an apple or an orange, how would you make such a decision? There are many theories out there how you do these things. State of the art is now evidence accumulation models. The idea of evidence accumulation models is that you accumulate evidence over time, and the time might be very short. So this might be just 1 second, but might also be longer. And you accumulate evidence for the apple, and you accumulate evidence for the orange. So both are kind of tasty, or might be tasty. And you make a choice. So you execute your choice when the relative evidence reaches a decision boundary. So if the apple is better than the orange to a certain degree, yeah, and then you say, well, I choose the apple over the orange. This is kind of the state of the art in decision science now, and these models can predict reaction times, choice times, and so on. So this is kind of a very good framework. So where comes visual attention now in? Well, it's kind of intuitive to think that, well, if I look at the orange, maybe I accumulate evidence for the orange faster than for the apple, because I think of the orange when I look at the orange, right? And also vice versa. And this is the idea of so-called attentional drift diffusion models, or attentional evidence accumulation models. And this is the first thing I wanted to introduce. It's the concept of a gaze bias. So the rate of evidence accumulation is kind of biased by gaze, where you look at. And I think intuition goes into the same direction. If I look at the orange, I think of the orange usually, and not of the apple. And if I look at the apple, I think of the apple. Why is this important? Well, if visual saliency and so on comes into play, and for whatever reason, I look at the apple longer than at the orange, or the orange longer than the apple, well, this will increase the probability of choosing one or the other item. And also in general, in information processing, you can break down your behavior into many little steps of decision making. Well, if your attention is guided, or visual attention is guided to one object, well, the likelihood increases that you proceed with this object, or at least think of this object, and that this information enters your following behavior. So visual attention influences evidence accumulation. This is quite clear now. And choice alternatives that attract attention increase their likelihood of being chosen. And you might now think, well, is everybody doing this? We conducted a study where we reanalyzed 4 data sets, and what you see here in the left is the percentage of participants with a gaze bias. It's nearly everybody, right? Across studies, it's nearly 90%. And here on the right, you can see the quantification of the gaze bias that we estimate here. And 1 is basically no gaze bias, and everything left of 1 is a gaze bias, and we see kind of big individual differences, but across individuals we see kind of a big gaze bias. So this is a very prominent thing in decision making, that your information processing is biased by visual attention, right? And therefore salient visual cues might be one driver of collective behavior. If there's something very, very salient, visually salient, well, many people will go for this because their likelihood of going into this direction is increased. Yeah? So this was one thing I wanted to give as an input from my research. The second one is internal information and input from memory. Well, here's something that is quite well known from social psychology already for decades, and the concept is called selective accessibility. Yeah. So how likely is it that information is accessible from memory? And it was quite nicely summed up already in a paper from 1988 from Feldman and Lynch. The conditions that influence memory accessibility. And I will briefly go through this. It's first of all, it's time since the most recent activation of that information. Makes sense, right? If you think of a specific piece of information, if you thought of this like 5 minutes ago, it will come to your mind with a higher probability than if it's a year ago, right? Then the amount of interfering material encountered in the same general content domain. Well, yeah, if you think of a specific topic and then there were many interfering information, well, the likelihood is not very high that it pops up in your mind, because it's more likely that you think of the other things in the general content domain. Yeah? Then there's elaboration and rehearsal of the original information. If you think and rethink of this and think of this again, well, the likelihood increases that it pops up in your mind in a specific situation. Then, of course, also coming to the individual characteristics of the information itself that determine the rate of decay in the respondents and the respondent's ability to retrieve it. Well, it's if it's very abstract and so on, and it's not so easy to memorize, well, it does not pop up so fast in your mind. And also your individual conditions. right? Your summarizing power in general, the abstraction level, the vividness, and so on play a role. Yeah, this also makes sense. Then we have motivation and processing goals at the time of encoding of information. I think this is very important in terms of collective intelligence, right? Motivation and processing goals. Where are we heading, right? How big is the motivation? Can we increase motivation? If motivation is high, well, at the point of encoding this information, I can memorize it better, right? And the likelihood is high that it pops up in my mind in specific situations. And then, of course, retrieval cues at encoding and retrieval. Well, if there is a specific cue that will give some associations about the specific information, well, I will think of it again, right? And Feldman and Lynch said, well, these conditions influence the likelihood, as I said, that any previously formed memory will be retrieved and used as input to information processing. So let me sum up collective behavior. So from my perspective as a non-expert, is likely influenced by individual information processing. I think this makes sense to go also look at the micro perspective. And individual information processing is subject to structural influences that are shared across individuals. And I presented to you two of them, the effect of visual attention and of selective accessibility of memory. And well, let me conclude with an example. What would you like to drink during the break? Orange juice or water? Well, you might now with a higher likelihood go to the orange juice because it's more visually salient here. What you see, it's orange, right? And I talked about the orange in my presentation. And therefore, when you make a choice what to drink, some association, some information about oranges that they are tasty might have a high likelihood to pop up in your mind while making this decision. Okay, yeah, then thank you.
Wonderful, Peter. Thank you very much. That was super exciting. Again, kind of this element of emergence, which also Al was talking about, that maybe something we can pick up on in the discussion later on. Also, I think you made a fantastic approach also to link already into Brian's presentation now, since you talked about information processing, right? So it's the individual information processing, and interestingly, this relates kind of to individual processes kind of in our human body and aspects of perception and behavior, but also certainly relates to the software we have at hand and the information systems environment. So maybe Brian, will you try to share again the screen again, or
I'm sharing. So I have shared my screen, Al. So I guess
that's there. It's there, Brian. It's all good. Brilliant.
Okay, so thank you. Apologies, I have a new version of Zoom and I had to change my preferences in security and privacy to allow sharing. So my fault. Anyway, so crowdsourcing software development, this is a study of that actual phenomenon in practice, and the title will become clear. Two's Company 1.6 is a crowd as I go through it. So, yeah, just let me tell you what the talk is about, I guess, first. So the basic promise of crowdsourcing software development is that you can get high quality software, can be produced quickly and at low cost by a large pool of self-selecting experts. So that's the premise. That's why it's attractive to people. It solves the software crisis. We pay too much for software. It takes too long to deliver and doesn't work very well. So with platforms that advertise they have over 1 million members, this seems like a dream for an organization. Unfortunately, in my experience, it isn't high quality. It isn't produced quickly. It's certainly not low cost. It's not a large pool, and they're not experts. So this was pretty negative view of crowdsourcing software development for the reasons. Some of the reasons are what Al and Peter have mentioned, actually. But there's a case study on this. This is a Fortune 500 company who did this, undertook a project in crowdsourcing. They didn't use a real name on the platform, and they didn't want to be known afterwards. So it's a pseudonym. But if I'd said the company name, you would all know them. They're a household name in the technology domain. So it's a very large company with 50,000 employees. The project was the following. So they wanted to try out a migration utility used by field engineers who were doing migrations for them. on a standalone tool on their computers, and they wanted to just create a web app instead. So the 128 screens that would have been on the standalone version had to be delivered through a web app. And they wanted HTML5, which they didn't have that kind of experience in-house. So they thought they would crowdsource it. So if you wanted, usually when I give this talk, I ask people to go to a website and put in the costings, how much you think it would cost to get this project done, 128 screens, how long it would take, and how many bugs there would be. And then I show you the result at the end. So it's a perfect example of testing crowd wisdom. But let me go through it. So this is the task. It's not a very complex task. And those 128 screens are broken down into these 5 categories of sub-project, basically, but different panels in each. So the company didn't prepare any documentation for the first, for the dashboards, because they thought that no documentation was needed. And they ended up producing over 1,000 pages of documentation subsequently for what they considered a very trivial task. So this is a fairly significant undertaking, and it was because the volunteers who were crowdsourcing were external to the company, so they didn't really understand the context, and everything had to be explained right onto the lowest level of detail. So this is a quote from one of the architect there, that it feels like we've produced 1 million specification documents, but the problem was that they had to produce specifications for things that were blindingly self-evident within the development community internally that would never have required a specification document. So those extra 1,000 pages are a significant overhead. Also, in terms of the crowd, what is it, a crowd? So, well, the contest, there were 53 contests to deliver those 128 screens, but only 84 people submitted anything. So you had a lot of contests that had no submission. Sorry. So you can see 720 people registered, and then only 84 people submitted anything, which is about 12%. So that's a really low crowd estimate, I guess. And that's why we get this figure of two's company 1.6 is a crowd. There's about 1.6 people on average in each competition. Finally, the cost. So there's a lot of detail here, but basically you are paying quite a lot to run these competitions. So you pay a first prize to the eventual winner who's decided this is the best solution. So that's the only one you move forward with. But you also, there's a whole lot of extra prizes here to encourage people the crowd to participate. So there's a second prize to the runner-up, but you never see that solution. It's the first prize is what you see. There's a reliability bonus, digital run points, which are all forms and incentives for the crowd in general to share money. And then you've got some reviews for the people in the platform who help you review the competitions and prepare the specs and so on. So, and then there's commission to the platform. So basically each contest costs $7,200, even though you're just getting the first prize worth of solution, basically. You don't see the other solutions. And then there's cockpit fees at $30,000 a month. So the cost, when it all added up, I guess was significant. So $650,000 for those screens, plus the extra overhead. So there's overhead in preparing the extra specifications, and also on a chat forum every day, the architect had to spend time in the chat forum explaining to the crowd how to do certain things and solve problems and so on. So it was a daily task that took a lot of time and effort. So the real cost was probably around $1 million for that. 215 calendar days, and 695 contest days, and 506 bugs. And the bugs are particularly problematic because there were repetitions of the same bug, because in each contest you had different developers. So, normally internally in a stand-up meeting, the bugs would be identified and they wouldn't appear again because the team would see what the bug was and wouldn't make the same mistake again. But because you had different people in every contest, you had this repetition of the same bugs, which is very tedious and time-consuming. So to wrap up, well, crowdsourcing software development is very costly in this example, and there are quality issues because the crowdsourcing competitions for software development are inevitably a waterfall. You have to declare a period of time for the competition, then you have to wait till the end of that period of time to get the result, and you have to choose the winner from potentially a lot of solutions, in this case not, but it's a waterfall, and you're trying to marry that internally with an agile process within the organization. That was very challenging. this idea, you know, the repetition of bugs was annoying, that domain knowledge didn't build up over time because you had different developers. It was a fleeting relationship. Every contest had different developers. And the crowd may be very small, as you can see in this case. We carried out a study of 10,000 competitions on the platform subsequently over many years, and increasing the prize doesn't make any difference, nor the duration. So that's an interesting kind of killers are a problem, that some people who register, just everyone else decides not to come, not to participate because they don't think they can win anymore. And the real conclusion, I think, is that crowdsourcing software development, the way the platforms are structured, the only reason crowdsourcing software development, I think, is being tried by people is because of the success of open source, which is a kind of paradox that people didn't think would be successful. But open source is so successful because of two key aspects, actually: transparency and recombination. So transparency means you can see everything any developer does. You can go and look at and see, because this code is open, so you can see how everyone solved the problem. And recombination, then you can, because you know, it's license free, so you can then take anything you want and put it together in different ways. So that's the secret sauce in open source. In crowdsourcing, you've got a competitive edge, and you're only seeing one solution, for example. So that recombination isn't happening. So the way it's currently configured, crowdsourcing software development, because of interdependencies and some of the things Al mentioned, it is very challenging. So it doesn't really work. So the conclusion is there really any wisdom in the crowd? And my conclusion, there isn't really much wisdom in the crowd for software development. So that's it. I'm happy to stop sharing screen, and I guess I'm back to you.
Thank you very much. This is very fascinating round of panels. I thank you very much, Brian, for also with this call to caution and this really nice in-depth experience in crowd-based software development. Before probably me trying to structure this all a little bit, I'd like to really open the floor now to the audience. I would understand the audience might have some questions and comments. I've seen some conversations already coming up in the chat there. But really now open the floor for the audience. Like, who would like to go first? Please just unmute and try and talk out loud. Would like to go?
Natalia, can I speak?
Lovely, go ahead. Yes,
Natalia. Hi, good to see all friends. I have a comment for Brian. So I often critique crowdsourcing for many things as well. And on the other hand, when you speak to companies like Topcoder, which I'm not sure if that's what your company used, right? Their pitch is usually not about cost savings, but rather about working on more innovative problems. And I'm wondering if they simply kind of put the wrong problem out there. It sounds like they were looking to save money. There wasn't much use of the creativity or wisdom of the crowds. And in fact, when the Topcoder CEO speaks in my class, he proudly says that the average number of submissions for 2 prizes should be 2.6. Otherwise, the people do not get rewarded. So I'm kind of wondering if this was just the wrong problem. Like, if you look at the problem NASA sources to Topcoder, yes. Comment on the nature of the problem, please, Brian. Thanks.
Thank you, Natalia. That's a very good question, and that is true. But Topcoder also state that you can achieve savings of 67% in software development costs. So they can't have it both ways. They do claim to that these savings are possible, and that's very attractive to companies if you could save almost 70% of the software development cost. They did say to the company, yeah, you chose the wrong problem, that what you should have done was put your specification up there and got feedback on that. And the company they were very pleased with the logo for the new web app, but a logo isn't worth $1 million. So it was the wrong problem. And what the company said, what Topcoder was saying was, yeah, you shouldn't be looking for solutions, you should be looking for more creative specifications. That's not what the company were looking for. And so I agree with you. It was the wrong problem in the way the platform is configured, because it doesn't solve your problem quickly. So, but I don't think it's clear when you embark on this kind of initiative that that's what you should be doing is the creativity part of it. That's not really made clear. So, but you are right. That is the defense. That it's the wrong problem. Don't look. You should be looking for some creativity rather than solving a problem or getting something done and say cost savings. It wasn't really cost savings either. The company were prepared to pay more for this, but they wanted really good HTML5 examples they could take on. And because it had to work across many platforms, they weren't able to do that. So the company were also wrong in that they were constrained, but they didn't really get much creativity though. So
Natalia and Brian, very, very nice. Thanks a million. Jeff, great to see you there.
Great. Jan. So Peter, I have a question for you. When I was thinking about things like recency effects and visual sampling and like that, do you think that kind of from a say a platform design perspective, would it be helpful if you ensure that people involved in collective decision making are seeing different things in different orders, or do you not want that because you want some signal to come out of their conversation?
Well, that's hard to say. So my answer would be it depends on the goal, right? And on the information they see. If it's motivating them to pursue the same goal, right, then it might be good because then individual information pops up, which is not the same, right? If it's more like the content is in the direction that the same information pops up, then you have no added value of the crowd, right? Then it's better to guide people to different things, that different things pop up, and the discussion has many more facets. So it really depends on the topic and what you expect them to pop up in their minds, right? If you set something and you expect them to have different things that pop up, then it's good. Then they go for this, and each of them gives their own perspective. This would be my answer. Yeah.
Great, thank you.
Wonderful, thank you very much. Great discussions. Who else would like to take the opportunity to talk to the experts in our panel? For the moment, then let me probably go and ask a few questions. Maybe that stimulates also questions or comments on your side. So I've seen now there's great sort of there is kind of this idea of great potential. So if more people would actually be able to collectively work on problems and solutions as Al has presented very nicely, I think, and there also is this aspect of kind of this collective behavior and intelligence emerging, which kind of then relates loads to the psychological perspectives, but also kind of Brian, I think, presented a great example of kind of a bit of a call to caution now. That stimulates my interest in kind of where do you see key challenges in making collective intelligence happen? From the examples we've seen here with kind of software development on the one hand and kind of logo design on the other hand, like what Brian commented just now, I think it relates loads to the context really, right? So to contextual factors. So where would kind of collective behavior and intelligence work better? Where is it meeting more the challenges? Probably the more complex the task gets, and kind of the higher the transaction costs might be. Like so maybe asking the panelists or also members of the audience, like, would we be able to conceptualize this a little bit? What would be probably more preferably contexts, and what would be probably key challenges anyways we need to overcome? So looking a little bit towards a future research agenda for collective intelligence. Al, would you probably feel happy or comfortable?
Well, yeah, let me respond to that. As I think about, I presented some challenges of how creativity and control have to effectively interact. But the first point of capturing the problem space, I think, really sets the stage appropriately, for that interaction, some of that cognitive dissonance that comes in between creativity and control, and that is you've got to bound your problem space appropriately, because if you don't really understand the goals of what you're trying to achieve in your project, and setting up, as Brian said, the specification appropriately for people to react to. So working within that bounded problem space is key to supporting the appropriate types of creativity you need in your project, as well as then as the controls you need to refine your solutions down to a feasible opportunity in your problem space. So what I found in my research over the years is if you don't bound your problem appropriately and capture it in ways that you can work with, then the whole concepts of creativity and control just expand to the point where it's almost fruitless. So I guess my point is that first step of capturing that problem space in terms of its appropriate complexity is essential.
Brilliant. Thank you very much, Al.
Maybe I could say I did mention it, but I really think it's important. Like open source has been so successful in training people and in offering creativity as well. It's it's really amazing, but it's the transparency and the recombination of the two key things. You can see how anyone else solves a problem, any problem. You can see how someone has developed code to solve that, and you can improve it if you can. But you can you can recombine things then that because you see all the different solutions. So it's the highest common denominator, that you're getting the best solution, then you're improving that. So those kinds of principles of being able to share. So it's not competitive in the sense of that you don't see anyone else, but you try to get the best of all solutions and keep moving forward from that, optimizing from the best up to concurrency, I guess, is the open source principle. Those are really important, I think.
Thank you very much, Brian. There's Scott raised his hand.
Yeah, thank you. I have a question for both Alan and Brian. You mentioned control, right? You talk about this notion of divergent thinking and sort of diversity and then control. And we think about sort of standard boilerplate complex adaptive systems. We think about sort of some source of variation or diversity and then a selection operator. And I found your use of the word control really provocative, and it spurred a lot of my thinking. But I wonder if you could just sort of riff a bit, or any of the three of you actually, on this distinction between selection in some simple sense, where you're sort of calling out the bad ideas, and controlling a process like this.
Well, I think your point is very well taken, and control is definitely an overloaded term, in this type of work. But I'm influenced by one of my mentors, Harlan Mills, who basically said that the most important part of software development is intellectual control, in that there has to be one mind on a team, and that mind has to be shared among all the team members to understand sort of the refinement, the hierarchy, the selection, if you will, that goes on during the project. So, yeah, I'm challenged by the use of the right terminology here, but I think control, in my mind, is very appropriate as a balancing of creativities and control.
Mm-hmm. Thank you very much, Al. Rob, I think you mentioned you put down a question in the chat. Would you like to?
Yeah, sure. It's so it was interesting. I think between the talks, the idea of the attentional evidence accumulation. And sorry if I'm giving that the wrong term, Peter. So that kind of suggests a sort of a positive outcome. Like I look at the apple more and more and more, and eventually I decide that I want the apple. But it seems when we talk about creativity and sort of agile development and these things, very often we narrow in on something, and on closer inspection, we realize that's not what we should do. So we kind of have to get specific in order to find a better direction. And yeah, I was just wondering how that kind of comes together. Like, does this idea of attention accumulating evidence leading to a decision, does that explain well these sort of negative decisions where we say, I don't want that apple?
Very, very good question. So I don't have a definite answer because it's ongoing research, and we're also doing this going from the abstract level, like we have an apple and an orange, to the what we cognitive scientists call it attribute level. Right, so it's not an apple and it's an orange, but it's a thing that has different attributes, and some of them might be negative. And when seeing negative things, evidence accumulates, of course, at a different rate. So it's not that what these models and the idea now is doing is you have such an overall average value of something, and on average it accumulates with the evidence with this rate. But of course, this might be different, and it's a very good question, and we're doing eye tracking studies on this now. So and it might be, and it's of course very important how attention is allocated. So do you first look at the negative thing, or first discover the negative thing, or do you discover it later? This might also explain primacy and recency effects, and so on. But I don't have a definite answer on that. So we're doing research on that. But very, very interesting, and I like that it translates into these other things like creative processes and agile processes and so on, that these are linked. This is also interesting for us as cognitive scientists.
Very good. Thanks a million. Maybe a last round of trying to conceptualize this a bit further. So I still have it kind of in the memories that when Brian concluded and said, like, he kind of has a feeling kind of this kind of in software engineering and crowd-based software engineering that it didn't really work very well, and so that kind of stimulated my thinking towards not saying it wouldn't work, but trying to find out where does it work, or where could it work, and so I'd like to ask each panelist two questions, and the first would be to please name characteristics of tasks of which you would think collective intelligence could be applied fairly well, and if possible, also to name a few examples of such tasks, right? I think that would be interesting. For me, altogether, it relates loads to division of labor in a way, and coordination also, right? And from that work there, we know also that in some aspects, some work you can distribute very well and coordinate efficiently, while others you wouldn't, and you would face more challenges. So against the background of what we have discussed, maybe could you name 3 characteristics of tasks where you say collective intelligence could be applied fairly well, and could you probably also name up to 3 examples of such tasks? Would like to go first? Who takes the challenge?
Well, I can jump in
very good.
quick. I think one of the key areas of challenge that in projects I've dealt with is trying to define what it means to have a good design solution. Because that varies widely among your team as well as your stakeholders. So, defining, the characteristics of, say, performance or security or privacy or, rationality, all the way up to novelty and innovativeness. People throw around those terms, but coming together with a collective intelligence and then really coming up with the appropriate way of judging goodness of a solution, and then as well as the evaluation and evidence that you're going to look for to measure that goodness, I think is a key task that this community really, has some research opportunities in.
Yeah. Yeah, wonderful. Thank you very much, Al. I think that's very insightful, relates to what Rob just wrote, right? That we can put out things to the community, to the crowd, and they kind of, evaluate it. That's probably one avenue where we can apply collective intelligence fairly well. Thanks loads, Al. Brian, would you like to go next?
So I can tell you what we looked at in advice to the company on what you should crowdsource.
Yes.
For software development. This is now, so bug fixing I think would work well in that model, even a competitive model to see who can quash the most bugs. But the three aspects for general software development, one was we looked where the least domain knowledge is required. So that was why the front end of this app would be appropriate. It should be self-contained. So because of the interdependencies of software development, and in all open source projects, they have to be designed to be modular, so you can contribute without affecting other people. You can control what you do. So self-contained is very important. And I guess the final characteristic was if you didn't have the resources internally. So it's scarce internal resources. If you have a lot of resources, then you don't need to do it. So you pick in software development, they were the three characteristics: domain knowledge, not a lot of domain knowledge required, self-contained, and you didn't have internal resources to do it, so you needed help. And they were the three characteristics for software development, I would say.
Wonderful. Thanks a million, Brian. Super insightful. Peter, any ideas on your mind? What tasks would you put to collective intelligence, or rather not?
Well, as I'm not at all an expert, I have nothing to add to Al and Brian. But perhaps from my perspective, keep the individual and its characteristics in mind, and just to think one loop further, and perhaps this gives more insights. But yeah, I'm not an expert, so I've nothing to add, really.
Okay, you have already enriched the panel a lot. I'm very grateful for that. And with respect to time, unfortunately, we need already to wrap up and conclude. Actually, like to thank you very much for this wonderful insights you have presented on a really innovative area. So I appreciate it very much. Also the openness, kind of the way kind of you were building on your specific background and shedding light on challenges and opportunities, and also the way how you engaged in the discussions. Also many thanks to the really to the great audience here, so many attendants, and really also so insightful questions. A big applause here to the drawing. I'm really impressed, I must say. Really big applause. Thank you so much, and have a great rest of the conference. Thank you so much.